5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
This is About Space, America's return to space, with news and information on our U.S. space program. Is your host of About Space, David Denault.
Welcome, and thanks for joining me today. It's reported to be the biggest technological breakthrough since the computer: synthetic biology. New to you? Well, I hope my report scares the hell out of you, so listen up. My report, it's live, but is it? Next, as America and the world is listening to About Space today. Ever dream of an island getaway at an all-inclusive resort? Or going on an island-hopping cruise to multiple island destinations? See sun-bleached beaches and swim in the azure waters of the Caribbean Sea. Call today for your special discount prices to your island getaway. This is a special offer for About Space by calling 877-747-8631. And let's go and explore the islands of the Caribbean. Welcome back. In many ways, this new technology is the computing revolution 2.0 because it is the computer revolution of the past 40 years, but applied to living things as opposed to computers. I'm talking about rewriting the code of life, a much bigger undertaking than rewriting codes for machines. Here's more.
What is it, life? What makes it different from just matter? Everything, living or not, is just chemicals made from atoms. These fish and the water the fish are in are just soups of atoms. But what makes the fish alive and not the water is how the atoms are organized, by a special kind of molecule, and you know this because you learned about it in high school, DNA. The double helix molecule that houses the chemical alphabet of A's and C's and T's and G's, which in different combinations can make a flower, or a frog, or you. Every living creature has its code that makes it grow, reproduce, and change. DNA turns dust into life. And how it does that? Well, now here's the mystery. 20 years ago, scientists learned to read a creature's entire DNA sequence, beginning to end, a genome, it's called. They did this for simple things like bacteria, and then for more complex flies, and eventually for humans. And then they began to tinker, to take the glow from a jellyfish and transfer it to a cat, to make critters do what they'd never done before. And as biologists got better at this, as Stanford professor Drew Endy, a new kind of science was born.
It's called synthetic biology. It's a means to an end.
What can we do with the new tools of synthetic biology? Well, we can improve on what's been spelled out over 3 billion years of evolution. We can take it beyond reading genomes or editing genomes and start writing genomes. Our own ideas of what life should be like, making creatures drastically different from any that have ever existed. And how do you do that? Well, already, one group of scientists have rewritten and rebuilt the entire instruction kit for the very humble little yeast. And they plan to put their new recipe into a cell, and if everything goes according to plan, it will come alive and begin making baby yeast exactly like its most unusual parent. It will be new in the world. This synthetic yeast will break the continuous chain of evolution that links every creature back to the first living cell. It will be discontinuous, in a way, a thing unto itself. And then where do we take this new technology? How far should we or will we go?
I want you to be sure you understand synthetic biology. Listen once more.
Or editing genomes, and start writing genomes. Our own ideas of what life should be like, making creatures drastically different from any that have ever existed.
I urge each person listening, no matter where you are or what country that you're in, go online and educate yourselves and your friends on the dangers of synbiology. It's being developed without any restrictions. It's alive. But is it? This Friday, join Dawn Meyer for another America in Space program and have your family and friends join us each week. Follow us on Facebook at aboutspace.today for launches and landings. And to all our listeners around the globe and here in the U.S., thank you for joining me today. I'm David Denault, and this has been About Space Today.